Assalamualaikum and good day. Today I will discuss about uh, the performance of active filters. So for this circuit, I have designed a low pass filter by using an inverting amplifier. So the gain of the amplifier is basically equals to the negative R feedback over R in, and the critical frequency is equals to 1 over 2 pi RC. Based on that formula, I have calculated the critical frequency will be around 106 kilohertz. So, in order to see the critical frequency, we need to generate the Bode plot, or some will say as Bode plot. So, we can simulate our circuit by selecting the AC analysis. And for this experiment, I will run from 1 kilohertz, I will perform it from 1 kilohertz to 1 megahertz. And for this instance, we will see the gain, the true gain of the circuit. And the vertical scale for now will be in linear. So as we can see, this is the frequency response of a low pass filter, which allows a lower frequency to pass through the system. So we can find the maximum gain of the system by moving the cursor to the lower gain and right click on it and add it and go to the next Y max to the left. So it will give us the maximum gain of the system, which is 1.499. So based on that result, we can normalize our frequency response by edit the expression. For the new frequency response, we will divide it with 1.499, which is the mid gain. So we want to plot our graph in decibel, so we can change our vertical scale to decibel. So we can simulate, and we will find that the mid gain is actually equals to 0 dB. So we can see that it's equals to 4 point something milli. Consider it as 0. In order to find the critical frequency, we just need to move our cursor to negative 3 dB. So I will set it to negative 3. So as we can see, the critical frequency is equals to 92.3 kilohertz. So it is actually almost accurate. So we can generate our data into Excel by clicking Export to Excel. So from this data, we can see that the left corner is for the frequency value. And for the B column, it is actually the gain in dB. So from this data, we can from this data of gain, we can find the V out for each frequency by reversing the order of the formula, which is 20 log times gain, 20 log of gain. So we can reverse that order of formula. That's it for the low pass filter. For the high pass active filter, I'm still using the inverting amplifier. The gain is still equals to the negative RF over R in, and the critical frequency is equals to 1 over 2 pi RC. So based on that formula, I have calculated that the critical frequency or the cutoff frequency will be 1.6 kilohertz. So since the gain is still the same, we know that the higher gain will be 1.499. So we can edit the expression by dividing it with 1.49. So we can see the frequency response. The frequency response is a high pass filter. So in order to find the critical frequency, we need to move our cursor. Better to use cursor 1. So move our cursor to the negative 3 dB. So as you can see, the critical frequency is equals to 1.5901. So it is equals to the calculated value. So the same method can be used to generate the data of the bot plot by clicking the export to Excel. And finally, we can simulate the second order low pass filter. So it is basically a multi-stage amplifier. We cascade the low pass filter with another low pass filter. So the critical frequency now is calculated by using a different formula. The critical frequency is now equals to critical frequency of low pass filter times square root of 2 to the power of 1 over n stage. So n is equals to the number of stage minus 1. So based on the formula, we now can get the critical frequency equals to 68.3 kilohertz. So if we simulate our circuit, so we need to change it to linear first to find the gain. So we can edit our expression to V out over V in. Okay, and then simulate. So we can find our maximum gain by moving our Ymax. So Ymax is equal to 2.25. So equals to 2.25. So we can normalize our frequency response by dividing our expression with 2.25. Okay, and we need to change our vertical scale to decibel. So as we can see, after normalization, our mid gain is equal to 0, and the critical frequency can be found by setting our y into negative 3. So as you can see, the critical frequency now equals to 57.8 kilohertz. It is almost exactly as our calculated value. So I think that's all. Thank you for watching. Goodbye.